Okay, Ron, I think you can get going.
Well, hello, everybody. It is podcast time once again for SBAU, our weekly little get together online and on Zoom of the Santa Barbara Astronomical Unit.
All right.
Are we on the air?
Yep.
The Santa Barbara Astronomical Unit, South Coast longtime proud telescope and astronomy club.
All right.
I'm Ron Heron, proud to be the vice president. Are we on or not? I keep hearing it, Tom. Are we okay? Santa Barbara Astronomical Honored to help bring the old radio show back alive on a Monday basis every week now at 11 a.m. each and every Monday morning. This happens to be our 7th program. We started March 1st of 2021. We'll let 2021 be our season 1, and it's now April 12th. And so this is series 1, episode 7. Let me introduce you to the brain trust on the screen for those of you joining us. Is 3-time president of the club, SBAU's beloved Jerry Wilson. Good morning, Mr. President.
Good morning.
You enjoying inoculation and pandemic quarantine same time?
Well, as best I can, I guess. Best as everybody else is.
All right. Below him on the left of the screen there is our incredible Chuck McPartland, who is our outreach coordinator.
Morning.
Am I hearing strange noises? Somebody got a cat or a kid running around? It's Tom in the upper
Tom
left.
and Wally, the dog.
Oh, the dogs and the cats. Okay, well, that's okay as long as I know what it is. As long as I know it's not me. Our incredible webmaster and distinguished technician, Mr. Tom Totten, is going to put us on screen and keep us off to the side when he brings up incredible graphics. May take a while, a few steps. Now joining us at the bottom right is Tom Whittemore, who is the former Westmont College science instructor, editor of our incredible newsletter, which is out and online in your inbox. Tom, good morning to you, sir. And baking some bread. I'm going to put it in order, you know. Uh-oh, you're not on.
Tom, you're muted.
You're muted, Tom. Hit that little microphone on the lower left and join us, please. Or maybe there's a box. Uh-oh, we do not have Tom Whittemore at the moment.
How's that? Here we go.
That's beautiful.
Okay.
And last but not least, ladies and gentlemen, active SBAU member Bruce Murdoch, who's also president and guiding force behind our Santa Barbara Theater Organ Society, mostly based around the Arlington, right, Bruce?
Yeah, it's installed in the Arlington, all 7,000 pieces, 20 tons.
Man, oh man, but I hope it's not rusting or getting dusted.
No, it's made out of zinc, spotted metal, which is basically solder, copper tubing, yellow pine for a lot of the pipes.
Yeah, but we know you. That's your main love, along with being a member of us. You go down and polish those pipes. Sooner or later, we'll hear them again. Gentlemen, I want to just launch breaking news. We sort of missed it, but we're on the tail end of International Dark Sky Week. Mr. President, would you like to tell us what that's all about? IDSW?
Could you mute yourself? We're getting a lot of background noise.
Tom, yeah, we're getting a lot of background noise, Tom.
Tom Whittemore.
We're hearing
really?
Maureen and Wally.
Oh, okay. I'll just mute it.
Well, unmute it when we ask you a question. I'll probably call for you a lot, Tom.
I don't know how to do that. So,
Well, it's the lower left, a little microphone. I found out over the weekend from the other Tom.
Or the upper right in your own picture.
Otherwise, invite him in and join
I don't
us.
I think that's the way.
Okay.
Have some
I
fun
muted
this
Tom.
hour.
I got him muted.
Technical
Okay.
difficulties. Okay, good.
So,
Okay, well,
international.
if you've ever seen, if you ever tried to do amateur astronomy, you know, the skies are getting brighter and they're getting more cunning at being bright because they used to be bright because of a lot of early on parking lot lamps that emitted in single bands. And so we could put filters on our telescopes and block them out. But now they've switched to LEDs and it's getting harder and harder to find really dark skies. As you can see in the pictures, there's a comparison of pictures, astrophotos taken. They're all multi-hour exposures with of the same set of galaxies. And it shows them under dark sky conditions and under increasingly illuminated conditions. In this case, we measure sky brightness by a Bortle scale from 1 to 8 or 10. Bortle 1 is very, very clear skies. So it's interfering with our hobby. It's interfering with astronomical research. And the places on Earth where you can get really dark skies are getting fewer and farther between. A lot of people that live in the cities have never really seen stars or the Milky Way unless they make a specific point of going to see it. So there's a society that started up in Arizona, and one of our members, Tom Whittemore, was, I guess, involved in that when it started up, to try and talk associations and governments into putting streetlight and other kind of outdoor light shades on things to keep light from going up in the sky. That light is really wasted for the purpose you want to use it for, and it screws up the astronomy. So, and also I sent a picture. Did you guys get a second email with a picture in it, Tom Totten?
Yes. Are you talking about the one that showed the street lights?
Yeah, the one with the street lights.
Okay, hold on.
The worst, the best, worst goes everywhere. The best goes just down onto the street. Yeah, I remember seeing that.
Just put the light where you want it.
Yeah.
Well, the big problem is that the street's 16% reflective on the
There it
average.
is.
Yeah, there it is. And so even if it's shaded down, 16% it's a double whammy, because the LED streetlights that they choose to put in start out with a very bright blue LED, and they put a phosphor on it to spread the spectrum out. Well, that blue light goes down, 16% of it goes up in the upper atmosphere, and since our atmosphere scatters blue light, it turns our night sky from dark to kind of a milky color. You just can't get away from it. And we don't see a color in dim light, so we see the sky as milk. But when you take a picture, like the picture I took, the 205-degree field of view of the Milky Way, overhead, the sky was blue.
Huh.
It
What-
wasn't.
So the International Dark Sky Week is trying to raise the public's awareness that they don't need to have wasteful lighting. It actually interferes with what they think they're trying to do, which is to make everything like daylight and therefore safe. But it doesn't really do that. It's harder to see in glaring bright light in a parking lot anyway. It's better over on the best side if the light just shines on the objects and not directly into your eye. So they're trying to, several cities have done this. They've taken on, declared themselves a dark sky city. And lights that are grandfathered in will be shaded, and new lights have to be, and our community is one of those. New lights have to be put so that you cannot directly look at the bulb. It's over like the best situation there shown with a street light, but that's for front porch lights and bug lights in your garage and stuff. Those things are now in California referred to as light trespass, and they're forbidden. Anyway.
Chuck McPartland, do you run into the problem yet out in your backyard?
Well, I don't observe from my backyard because there's too many trees. So I just go out in my driveway out front, and I'm maybe 50 feet from a bright street light, a bright new LED street light. So it's pretty glary, but luckily most of what I do is fairly light pollution insensitive. So I can get away with, I just need to see a star disappear to do the occultations. But if we were trying to do a star party and show people things, yeah, that could be a problem.
Tom, could you put the street light one back up?
Sure.
Thanks.
While you're doing that, I'm going to ask, what's the big advantage of LEDs? Light emitting diodes, they're not hot, are they? They're more efficient?
They do get a little hot, but they're far more efficient than other lights in terms of electricity usage. And they last a lot longer than incandescent bulbs.
Wow.
And so because of the environmental savings in electricity, that's why incandescent bulbs have been outlawed.
Well, we went from incandescent to the high pressure sodium vapor to LED streetlights. And the high pressure sodium vapor we had in my neighborhood were 42 watt lights. They replaced them with LEDs, 130 watt LEDs. So you get an increase in the power going into the bulb, and the bulb is more efficient. So you get a lot more light pollution, and they just don't get it.
That's why we're trying to raise their awareness.
Yeah.
Well, it seems like two sides. We're in a minority on one side needing dark, but the rest of the world wants to light up, become Vegas.
Well, you know, I've been on the Isla Vista Recreation Park Board for 4 different terms, 16 years. I'm not currently on it. And back in the 1990s, I think of 1993, we had a downtown park called Antikythera, which was illuminated by 3 500-watt sodium vapor lights on the side of the building. And so that park at night was either intensely light or intensely dark, depending where the shadows were. And nobody used it. Everybody was afraid to go through it, except the homeless who were sleeping there. And so what we did is to remove those 3 500-watt lights and put in 16 poles throughout the park with 22-watt curlicue fluorescents on them, trim the trees up and the foliage. So the park was illuminated. It wasn't brightly illuminated, but it was uniformly illuminated. It was like, you know, a strong moonlight. And guess what? People started using the park at night. So you don't need these intensely bright lights. What you want is even illumination, and they don't get it. You know, on Del Playa Drive, which is the street I live, on the other side of Camino Corto, they've replaced all the street lights with 2 per pole, 130-watt LED street lights, intensely bright. It's like daylight. But between one pole and the next, it's dark. So you're just like you were saying, it goes light, dark, and that's not what you need. But they don't get it. The politicians think that brighter is better, is safer, and that's not true.
Well, back in my days of embracing video or videography, if you will, I had learned, in fact, it was a short-term course I took over at Cable Access to do my own little program, that there's 3 kinds of light, right? There's white, there's blue, and there's yellow. Which is the LEDs?
You can get LEDs in any color you want, from ultraviolet through infrared.
Okay.
You know, it's how they dope the semiconductor when they make it.
Well, we're not going to ignore this next year. Mr. President, is International Dark Sky Week the 2nd week of April?
It was this year. I think it's the same every year.
Okay, and this started, somebody
Try
said
to put it close to Earth Day, so there's Earth Week too.
Aha. Hey, Earth Week is coming up in another week, along with my birthday, which I'm not going to celebrate.
Oh, happy birthday.
Well, shall we get
Happy
into
birthday.
Ron, let
Yes.
me ask, what is this thing called the Bortle scale? Where'd that come from?
Well, don't ask me. I don't know.
Mr.
Bortle's a
Bortle.
cometary astronomer who came up with this scale for rating how dark a sky is.
Huh. How dark a sky is. Okay. They got the problem solved in Ojai Valley, but I guess the cities are getting worse. Same amount. Where does the energy come? The energy is powered by solar a lot more these days than in the old days.
Yeah.
So the energy is changing, but the lighting is getting more efficient, and the LEDs just screw things up for astronomers, don't we?
Yeah, the big limitation, as you saw in Texas, is our network, what do they call that? The web, or the network of electrical suppliers, the grid.
Oh yeah, yeah.
So that thing is ancient. It's patched together. That's why we keep having so many fires here in California, because the wires break in the wind. And so they're trying to, it's going to cost a fortune to upgrade that. So they're desperately trying to cut down on energy usage. So,
And it's not just astronomers. You know, that bright blue, especially the blue light, affects circadian rhythms in people and causes all kinds of health problems. And it messes up nocturnal animals and, you know, insects, all kinds of things that depend on having a nighttime.
Tom Whittemore, do you notice a difference in your viewing?
I just rejoined you, so I missed that. We had a friend come to the door, and I really wanted to see the friend, so I had to leave for a little bit, but I'm back now. So what are you guys talking about?
dark skies.
Light pollution.
Light pollution.
Dark
Actually, we're
Sky
just
Week.
finishing that.
Yeah,
My question is, have you noticed brightness, more brighter evenings where you live?
Oh, absolutely. Well, I've been coming down here to visit Maureen's mom since 1993. And in 1993, in the summertime, I could lie on my back in the backyard and I could see M13 with my naked eyes. It's hard to do that anymore. The light intrusion is especially bad to the southwest of us, okay? The sky to the northeast is still pretty good. But absolutely, in the almost, 30 years now, almost 30 years since I've been coming down here, the light pollution is extreme. But for me, coming down here still is a treat. I mean, being here is still a treat because the Bay Area is blasted with light. And I was building larger and larger telescopes to see fainter and fainter things, and I never could because of the competition of the because of the background sky. And Jerry, I was not involved in the creation of the dark sky. I was one of the first members. I just joined them because they came out of Tucson. Okay. And I kind of forget when this happened, but it was probably in the 90s, is my guess, when it was born.
That's okay. An early member is good enough for me.
Now, I've got a couple of questions from Tim Crawford on YouTube that he's typed in. And so let me ask the first one. It says, he doesn't still understand why we can't ask for shades like the best in the image is showing. There's a shade on that light in that image that Jerry had up of the International Dark Sky streetlights. But I think we do have shades available, right, Jerry?
We have them available, and actually there's streetlights on Cathedral Oaks right behind my house. And because they shine in the backyard, several of us, myself included, called the whatever the utility company is for that, and
Edison,
asked for shades, and within a couple of weeks they had put them on, and it cut down the light in my backyard tremendously. Plus, it's also the law now. You have to, in California, you're responsible for keeping your light as a homeowner in your yard. And so if you're grandfathered in, they're not going to make you change it. But any new housing or when you change lights, you want to remodel, you must have shades that you can't see the actual bulb. And the shade points the light down to illuminate your yard, but doesn't illuminate the neighbor's yard or the neighbor's bedroom windows or anything like that. So look it up. It's called light trespass.
I tried to get a better shaded light for the one right in front of my house, and it took me 6-7 months of dealing with it's their fault. No, it's their fault. And finally getting to Southern California Edison that owns the pole and contacting them. And they did put in a better shielded light, but they put in a brighter light.
Okay. Well, that's because you guys live in Goleta. See, we're in the city of Goleta, so they're more responsive to us.
But it makes one wonder how the poor astronomers in the clubs of the Bay Area, like you mentioned, in LA, how do they do it? They have to go out, drive for miles, don't they, outside of town?
Yeah.
Right. We used to do a lot of our viewing up in the Santa Cruz Mountains because the view to the south was basically over, the ocean. It was beautiful. Okay. I remember that's the first time I ever saw Omega Centauri was up on that mountain. So
wow. Gentlemen, if you don't mind, I've got an announcement. This is our regular weekly podcast of the South Coast Longtime Astronomy and Telescope Society Club, Santa Barbara Astronomical Unit, live on YouTube on Monday mornings, 11 to noon. We would like to invite everybody, even your family, you and your family, to join us, even during the pandemic, and learn and explore the constantly evolving and fascinating stories we're going to be talking about here in a minute. Space news, rocket launching, all kinds of probes out there, heavenly bodies, NASA, what they're doing, the private corporations now. And in going to the moon, by golly, you want to talk about Perseverance real fast in case we miss it, and then go to the nightly sky, gentlemen? Jerry, what's the status on the helicopter?
Well, they were going to fly it yesterday, the 11th, and they started out doing a low-speed rotor test, and the Ingenuity failed that test. So they put off the flight attempt for a few more days while they work on passing that test.
Is that the first moving pictures we've ever gotten from Mars? I don't recall seeing any videos from Mars before.
They have made videos by pasting together a lot of still pictures that makes it look like the rover is moving. But they do have videos, low quality videos of the rotor turning on the Ingenuity.
I heard or read that those rotors are going 50 RPM. Or, yeah, just under a rotation.
3,000 RPM.
Well, that's the test is 50 RPM, and it didn't do well. When it's flying, it's going to be way higher than that.
Really?
Yeah.
So what we're looking at is not really a video. It's a 2 or 3 pictures.
No, I think that's a video. Well, what is a video but a bunch of still pictures?
Well, that's
It looks
true.
like a GIF.
Yeah.
Okay. And so do we know when NASA's going to fly it?
They said they'd announce something today on their plans for doing it, but I haven't seen that yet.
I've seen the earliest they're going to try is the 14th because they've got some stuff to work out.
That's Wednesday. Okay. And overnight, for some reason, I guess that's daytime on Mars. Wasn't it?
Mars has a day and night that corresponds within what, 20 or 40 minutes to our day and night.
Okay. Well, I had heard that it was middle of the night or midnight or past midnight that they were doing all this.
It's their day is 40 minutes longer than our day, so it gradually precesses. So the people working on projects like this even have special watches made that run on Mars time, and they gradually precess into working at night and then back into working in the daytime as the project goes on.
Aha.
So Chuck, do the watches, are they 24-hour watches? Or are they 24 hours and 40-minute showing watches?
Yeah, they're 24 hours and 40 minutes. They had specially made watches.
They have a mechanism for that, probably by Rolex. No, I'm just joking.
Hopefully not wanting to embarrass anybody, but I want to ask Bruce and Tom Whittemore, do you know what a day on Mars is called?
Oh, is this a joke?
No, it's something I just learned.
Oh, go ahead.
All right. Jerry, you want to tell us?
Called a soul.
Yeah, it's called a soul.
Okay.
SOL. And it's what, 40 minutes longer, or it's a little longer than 24 hours?
Yeah.
Okay. So we'll monitor that, I guess. You want to talk about the night sky or Asteroid 4 Vesta? Anybody watching that in the evening?
So
No,
why is it called 4 Vesta? What's the number 4 mean?
That's the order in which the asteroids were discovered. So it's 1 Ceres, 2 Pallas, so on and so forth.
Well, it's making a tight turn in Leo tonight, 1 degree east of the magnitude 5.5 star, Leonis, 51 Leonis.
Yeah.
Okay.
Between
Zosma and Algieba, 2 stars I've never heard of.
Uh-huh.
Oh, you haven't heard of those?
Yeah, I have.
Oh, I meant the Baron.
I haven't heard of. I mean, I'm way behind on my stars. Oh, here we go. We're going to call up some views of the sky. But you can see this. How often can you see an asteroid with the human eye, with the naked eye?
This is just barely visible naked eye from a very dark spot. You need binoculars to see this.
Oh, is
but
that right?
occasionally,
Tom, would you show the picture I sent with this?
Sure. You're talking about the galaxies?
Yeah, the triplet.
Yeah. Hang in there.
Shows the 4 Vesta asteroid.
No, there's no 4 Vesta asteroid in there. This is the background it will be against.
Oh,
The bright white star that is suggestive of it being the asteroid is actually a star. But these are M65, M66, and the one separated up above it is an NGC number, but it's referred to as the hamburger.
oh, I see.
So
it's more like a hot dog.
Oh, yeah, there's a difference of opinion on that.
But
So
now, is this asteroid a dwarf planet?
No, it's not. It's an asteroid. It's not spherical or close to spherical.
Yet we can see it, but we can't see a Ceres or that other one that are.
You can see Ceres when it's at its brightest, just barely.
Yeah. Now, Vesta,
Naked eye or in telescope?
Naked eye.
the Ceres, which we talked about last week, is different than Vesta. Vesta, for some reason, is an object that was at one time molten, and it developed a core, a heavy element core, sort of an iron-rich thing. So it is differentiated. Ceres, which is larger and rounder, does not have a core. It was never molten. It did not differentiate. It's got the innermost layer is a mantle. So on this one, on Vesta, even though Vesta is not a dwarf planet because it's not round, it was molten. So how an object that was molten did not end up round is a little puzzling. But I guess Chuck says that it was due to collisions or something after it was formed. So that's probably true.
That's one of the hypotheses.
Yeah.
For the benefit of folks that don't know, I do know this. The asteroid belt is vast and it's between orbits of Mars and Jupiter.
It's
So
vast.
we're looking out past Mars, maybe not in the same direction, but we're looking into that asteroid belt and there's only a few biggies and the rest of them are all just junk, right? Pieces of ice and rock and billions of them, I guess, right?
a lot of them.
Asteroids were not once a planet?
Some were, maybe.
Maybe.
Some were maybe planetesimals, but if you took all the asteroids in the asteroid belt and smushed them together, you couldn't even make something the size of our moon.
Yeah.
So how in the world?
The proximity to Jupiter with the tidal forces that it caused in that region of space has prevented those asteroids from ever conglomerating into a planetoid.
Wow. How do you suppose it got molten?
It got big enough that the internal heat plus radioactive elements heated it up.
Gravitational contraction and the friction among the elements when it squeezed together, that it made it molten.
Huh. And it
Do you see that? Do you see that picture on the screen, that rotating Vesta right now? That looks like there's a line all the way around its equator there. It's I don't know why that would form that way.
Yeah.
That's it.
There's a very large impact basin at what they call the south pole of it, called something like Rhea Silvia, and those may be where shock waves came through the planetesimal after that impact.
Are there plans to land on it?
Not yet that I know of. We've orbited it, as you see from the quality of these photos.
Oh, sure. And
there's that snowman again.
Oh, I see. Which ones?
I wonder if, oh, go ahead.
Bruce,
I wonder if Vesta was bigger at one time, because you can see all these striations that are kind of parallel, like it's part of something that was bigger.
Well, they think this is the core, mostly the core of something that was a larger planetesimal.
Okay.
I don't know why all those asteroids, the bigger ones anyway, just don't knock around and hit each other like on a pool table.
There's a lot of space between them.
Is that what it is?
Yeah, don't believe the sci-fi movies.
Yeah.
The average space between decent sized bodies in the asteroid belt is something like 1 million miles.
But why wouldn't your series and the bigger ones start grabbing all the rest? Or maybe it does.
Because they're far away.
Yeah.
But we get one in here every so often. It scares the P1 out of us because it goes by the Earth.
Yeah.
Okay.
There are asteroids that seem to be pieces of Vesta, and that's what I think Tom is showing here. They're called Howardites and Eucrites and things like that.
Chuck, there's a rock on the screen. You want to do your older than dirt lines?
Well, this one is probably not older than dirt, because this is, I think what Tom is showing is one that's a piece of Vesta. They think is a piece of Vesta. And there's a class of 3 of them. There's a 3-letter acronym, and it's Howardites and Eucrites and something else. So HETs or HEDs. HEDs, I think it is.
You think Vesta's younger than the Earth?
No, but these pieces have been, molten and resolidified from impacts and stuff, so that the age of formation on them is probably less.
So it was manufactured after the Earth.
Well, everything came from the original batch of dust swirling around. It coalesced into the sun and the planets, didn't it?
Yeah, eventually a long time ago, we were a cloud of swirling and turbulent gas that collided with itself and dust particles and picked up a single dominating angular momentum. And then we flattened it. And with that, we flattened into a disk under gravity. And then local swirls began gravitationally attracting the other particles in most cases.
But
this is that Rhea Silvia basin, the big impact that Tom is showing here. And some of those striations that we saw were actually ridges going around close to the equator, of the Vesta here. And farther on in your stuff, Jerry, you're talking about Iapetus, and it has a large ridge that goes right around its equator. And what they seem to be is where the planet was hit by a large object. There was probably a cloud of debris around it that formed into a ring or a small moon that subsequently was recaptured by the protoplanet and broken apart tidally and distributes itself in a ring right at the equator that they think makes.
I've heard that. I've heard that. Yeah, good one. This one, stay on that, Tom. This one shows, like you guys have pointed out, the ring pattern around the bottom there, and that I read where that could be formed when the whole thing was mostly molten but had a thin solid crust, and then it was hit. Something went in there, and so the crust cracked radially, and the lava reformed, and the ridges remained.
Huh.
So,
you know, there are some big round bodies in the solar system that I've seen, and I swear I don't know what they are. Maybe they're moons around the outer gas planets. Like there's a ball that looks just like the Death Star in Star Wars. It has a big, huge round. What is that? Anybody know?
That's Mimas. That's one of the moons of Saturn.
yeah.
Okay. And then there's a ball that has some bright white spots on it. That's not this one, but what is that one? What are the white?
That series, the asteroid series, has a couple of really bright white spots on it.
Right.
And also Callisto.
What's that?
Also Callisto.
Okay, that's a moon.
Yeah.
One of the moons of Jupiter, yeah.
Right.
One of the Galilean moons.
But Ceres, there's an ocean, or there's a lot of salty water underneath, and it broke through and it deposited, the water evaporated and deposited these really white salts on the surface.
I guess there's no two bodies, be they asteroids or moons, that are alike. They're ones that are
different. They represent an incredibly an incredible supply of very easy resources. For a lot of these things these asteroids have, you have to dig very deeply on the Earth to try and find traces of them. There's one asteroid, I think it's Phoenix or Psyche, it's Psyche, that is made out of mostly metals, many of them precious metals, and is worth some incredible umpteen skyrillion dollars to the first who gets there and starts mining it. Now, some of these asteroids are iron-based. They're solid. You can go in there and you can mine the iron. I'm talking very far in the future. Mine the iron, hollow the thing out, and then put a door on the mine shaft and fill it with air, and it becomes a base where you can live inside.
Wow.
So, I read a lot of science fiction.
For those of you who watch the Alien movies, it was called the Nostromo, wasn't it? A big ore carrier.
Spaceship, yeah.
Yeah. Gentlemen, would you like to offer our services to schools or organizations? Our outreach coordinator, Chuck McPartland, would glad to take a call. You've gotten some calls lately, but they're not virtual requests, are they? They want you to bring your telescopes. We're not ready to do that yet, are we?
Right. As a group, we're not ready to do that yet.
Okay, but we will in time. Shall we go to the night sky?
Sure.
Some stuff happening tonight involves a comet. Anybody watching Atlas, old C2020?
Let's see, where are you? Oh yeah, Monday. No, it's been cloudy here for me. And before that we had wind. My telescope doesn't work well in wind.
Is that right?
Neither does mine.
Yeah.
I actually had a flying saucer in my yard after the wind. The neighbors have some of those gas heaters like you see at restaurants.
Oh.
Yeah.
And it blew the top off of one of those and it ended up in my yard.
Call those mushroom heaters.
Yeah, a couple of our neighbors' umbrellas landed in their other neighbor's yard.
Well, let's see. Asteroid 3 Juno, located in Ophiuchus. There's my favorite 13th house of the zodiac, is in the sky tonight. And I guess you guys aren't going to be out there because of the damn international dark sky or light sky.
No, you can't see the sky.
Can't see the sky, just the opposite. This is the first time I learned about Dark Sky Week, but we're going to honor it every year. Tomorrow, Tuesday, gentlemen, 4/13, moon path.
Let me make a comment about Juno, because now we talked about three asteroids. The thing is, when you look at these in any size telescope we have, you do not resolve these at all, even into small disks. They just look like stars. So you have to spot the asteroid, you have to have made a star chart or look at a star chart and look for the star that isn't on your chart. And then look a couple nights later and it will be moved slightly. You can take pictures to compare and make a montage of the path of the asteroid. But optically, you have to look for motion.
Huh.
The name asteroid actually means star-like.
Yeah.
And it was kind of a term that Herschel coined, sort of making fun of Olbers in this crowd that were calling Pallas, Juno, and Vesta planets. He was saying, no, they're not planets. They're asteroids. They just look like stars, and that name ended up sticking.
And I learned somewhere in the talking points from the president, there's another asterism up there. Maybe it'll come up and.
Oh, there's many of them, but Juno is in this highlight this week because actually it's stopped moving. It's not moving against the background. It's changing from retrograde to prograde motion or the other way. So it's coming to a stop and then it's going to back up. So it'll take you longer to spot that in the next few nights.
And that's just apparent motion. That's not actual.
Right. Yes. Let me ask you the question of the day.
Uh-oh.
So
go ahead.
These things, like Chuck just pointed out, these planetoids and asteroids and the planets too, they move for a while and then they stop and they back up for a while and then they stop and then they go forward for a while. And that led the ancients to believe that the Earth was the center of the galaxy, or the center of the universe, and that the heavenly bodies moved in hypocycloids, complex curves around the Earth. It wasn't until it was hypothesized in very early times by Aristarchus that it was actually solar centered, but that didn't really become official until recent 1500s or 1600s when Copernicus published his results. So the Antikythera mechanism, which was discovered and is an astronomical calculator from ancient times, is that based on an Earth-centered or a sun-centered solar system? That's the question of the day.
Well, it answered it.
The answer is written right below it for those of us that can see it. So should we let people call in if they want, or should we just tell them?
Let's just tell them, because I've tuned into a YouTube 1.5-hour video. Some British guy is an expert on it. Maybe that's him. I don't know.
Okay.
And he lost me after about 20 minutes into his speech, trying to figure out all those gears. The thing was crusted.
They've made models of it now through CAT scanning it, and have made working models of it. And you can buy it if you want, or you can get the plans and make it.
Oh, it still works when we do a copy?
Well, the one that they found is all encrusted with rocks. I don't think they've completely freed that, but they've looked inside of it with scanning techniques like X-rays and CAT scans, which is an X-ray, and decided what's in there exactly, and have made working copies of it, which I'm sure if you wanted to, you could obtain.
Yeah, they used X-rays to look at this chunk. They got it off this.
It came from a shipwreck. It's estimated to have sunk about 200 BC, before the current era, BCE.
Right.
And so the Antikythera mechanism may have existed for decades or centuries before that. So is it based on the Earth-centered or the sun-centered solar system to predict the motion? And the answer is neither. It predicts occurrences in the sky based on empirical observations. And it's just as accurate for sun-centered, or it doesn't depend on either physical mechanism. The physical mechanisms were not embodied in this. It's just empirical.
Right. They'd seen the timings on a lot of things, and they just made the gears do the timing.
Right.
Well, wait a minute. Are they turning the gears by
Yeah.
hand?
Yeah, you
Yeah.
can see the picture that's up right now that Tom has up. There's a crank there.
Yeah.
And you turn the crank after making some settings. And there's actually instructions engraved on one of the parts of the structure of it that they've been able to decode part of it. And so you do some settings and then you turn the little crank and it'll move you into the future or the past. Mainly they used it in the future looking for planning stuff like Olympic Games and things.
Yeah.
Really? And then they would look at this and I guess they had degradations or whatever around the edge and be able to tell where the moon's going to be, where this star's going, where that retrograde planet. It's all in there.
And eclipses.
Yeah.
Tom Whittemore or Bruce, have you heard of the Antikythera mechanism?
Oh yeah, I've seen the the plexiglass thing that they showed there. There's a whole series on YouTube about it.
Yeah, and somebody came to the club one time and talked about it.
Yeah.
And there's a good book called Decoding the Heavens about it.
Yeah.
Okay.
The picture you see right now up there, that's what the Antikythera mechanism actually looks like. That's as clean as they ever got it.
Yeah.
So they consider this genius from 3,000 years ago, but it would have no practical use today.
No, it has the same use today if you're interested in doing it. We have software that'll do everything this does now, so there's no need to have that unless you collect antiquities.
Well, would it be different if it were sun-centered or earth-centered?
No, no.
It wouldn't be different.
This is just based on empirical observations.
Yeah.
Doesn't assume any mechanism.
Did they believe back then that the center of the universe was the earth?
I have no idea. I don't know any way we can tell that. It's mentioned in philosophical context both ways.
And what do you call a deer with no eyes? No idea.
Tom Whittemore, you're going to have to give us your pun of the week.
Well, yeah, actually, I was actually about to do that when you had Vesta up. And you guys were talking about those, striations around the belt.
Yeah.
And I said that I would have said that they were known as vestibules.
Little plays on words.
Okay.
Do we want to do the rest of the nights of the week?
May I just add 2 cents to Leo, since it's one of my favorite constellations. Early in my mirror making career, I used to use, you guys, there's a star there, I pronounce it Algeba. It's also known as Gamma Leonis, and it's a beautiful gold double star that are fairly close together. I can't remember how many arc seconds, but maybe a few. But I used to use that star to diagnose whether or not the mirror I was crafting was pretty good or not. It's just a quick and dirty look at the quality of the optics that I was working on. Again, I work on mirrors for telescopes.
Sure, you and Tim Crawford. Incidentally, that brings up tomorrow night, Tom Totten. Are we online for virtual?
Yep, we're going to be the normal telescope workshop from 7:30 to 9 p.m. That if you're a member or know us, you can send an email to us and we'll try to get you set up to participate.
What's the most number of people you've had on the screen at one time on a Tuesday night?
I think we had a dozen at one point.
Wow. Just a quick question, so we cover lots. Does anybody know if they're still going to launch the incredible Webb radio telescope in October on the 31st, Halloween?
That's the projected launch date, but I have no idea if they'll actually launch it.
Yeah. Another thing is, if I haven't beaten the death out of Oumuamua, there's a whole new look at it. Okay. And, after having bought Avi Loeb's book and read through it a couple of times and everything, it's now believed that Oumuamua 1 was not a starship. It was likely a breakoff from a Pluto-like planet in another stellar system, okay, that just came through our system here. And I guess the Vera Rubin telescope is going to be trying to find like one of these things a year, passing through our neck of the woods. But there have been a couple of really nice articles. There was a really good one a couple of weeks ago in the Tuesday New York Times Science section that talks about the new idea that this thing might be of frozen nitrogen, okay? And that's why it looks so darn shiny when it went through. They also said it looked like a buffalo chip. Okay. So there's a lot of new stuff. The latest Science News that Maureen and I got also had a nice little summary article on this. And, you know, maybe, what's his face? Avi Loeb is, you know, I don't know, maybe he's a little embarrassed now about, you know, calling the starship. He got people thinking anyway, huh? So
My impression was he didn't say it was a starship. He said it's possible it was a starship.
a sailcraft.
He didn't say it's probable. He said we must look at all possibilities.
Right. That's the good thing about Avi's, you know, looking at it differently, you know, shakes up the boxes stuff, huh?
Yeah, exactly.
Yeah.
Looks like a Havana cigar to me, but
yeah, it's just too darn far away to get any sort of detail on it, even with the Vera Rubin.
Yeah.
So,
but it's long gone. I don't understand.
Yes. Yeah, it was only around for about 11 days. 11 days, you know.
11 days it came through?
Yeah, they got looks at it for about 11 days. And it was zooming out of the solar system by the time they took a look at it, I think.
Yeah.
And it's not yet out completely.
That's correct, Chuck, yeah. Mm-hmm.
And its trajectory altered by our sun quite drastically, didn't it?
Yeah, one of the big questions was why it gained a little bit more velocity than, you know, gravity would be responsible for its, you know, when it left us. And now the thought may be that it was basically triggered by some nitrogen sort of boiling off and giving it a little rocket boost. But there's been a lot of good literature lately on this thing that's pointing to nitrogen, okay, and also maybe to its shape.
But frozen nitrogen is glossier than frozen water, for example?
Yeah, you know, so the articles do point to its shininess, its albedo power, okay? And it was shiny, and they talked about how, you know, planets further and further out in our solar system, or things further out there, do contain, you know, nitrogen, quite a bit of nitrogen, okay? And so this might have been a breakaway from another star system. You know, who knows, right? Who knows?
Yeah, well,
it's very interesting. It got the astronomical community to really talk a lot, which is pretty good.
And 2I Borisov, the comet that was also had a lot of nitrogen content. So.
Yeah, I think they're really, Chuck, they're pointing to, you know, nitrogen as basically the main constituent of this guy.
So the Borisov was not an intergalactic visitor. It was one of our comets from the
No,
Earth.
it was an intergalactic visitor.
Right, it came from outside.
Oh, it did.
Mm-hmm.
And they're both passed away. I'll tell you how I know that Oumuamua wasn't a spaceship. I would imagine if there's intelligent life that could get here, it would know where our sun's zone was, you know, the Goldilocks zone. And hey, that third planet, let's veer over there. Let's make a left turn and check that out, you know.
Yeah.
We got about 11 minutes left in the program.
Okay.
What do you want to talk about? More of the
Ron, I have a question from Tim Crawford again, and he says, does the asteroid belt act like a shield of some sort to the inner planets?
Ooh.
What's the answer?
Okay, who's going to answer that?
They provide ammunition.
I was going to say the same, a reservoir.
They're way too dispersed, and way too much space between them.
Yeah.
To act as any kind of shield. The biggest shield against and also for changing things to head for us is Jupiter. If they come near that, they'll give a gravity assist to God knows where. Anyway, let's go on to Wednesday. The Lyriad meteor shower will start.
Yes.
It's a medium. It's not a high density shower, but it will peak. I think on Wednesday, in the coming week. A few sporadic meteors shooting across the sky in the early morning hours.
Like one an hour, one a second, one a minute.
Doesn't give a numeric thing like that.
But it does say, Jerry, in your notes, it says 18 meters per hour at the peak.
I don't see that, but that's okay.
But our dreaded light pollution.
Oh yeah, there it is. Yeah.
Keeps us from seeing a lot of those 18 an hour.
Sorry, Bruce, it says 18 meters per hour expected at the peak.
It's not bad.
No.
Okay, and the reason it's the Lyriad, what's that name mean?
Comes from, it has a radiant where they appear to come from is in Lyra, up near Hercules.
Well,
My
18 meteors
understanding-
per hour is like one every 3 minutes.
Yeah.
Yeah, but my understanding is we pass through the remnants of a comet tail when we hit one of these meteor showers.
Yeah, something like that. It's a band of debris from either a comet or an asteroid or something.
So when a comet comes through and leaves that big tail behind it, that tail is not just gas, it's also little particles or
That's right. Dust. Mhm.
All sorts of crap.
Mhm.
all right, we'll watch for that for a couple of weeks.
Okay.
Also, let's see, Mars on Thursday is bright in the western sky after sunset. Getting
Yeah,
some,
it's really beautiful right now because the other night I was showing some friends, wearing a mask and everything with my laser pointer out in the front yard, the skies, and Mars is up near Aldebaran, and I got confused who was who, okay, because they're both very red and fairly bright, but it's still worth going out, at least with your eyeballs, and looking at Mars. It's quite small, for a telescope. So,
Ah.
That Saturday night, it kind of looked, it's up in the horns, and it kind of looked like,
Yeah.
3 horns on Taurus.
right, that's why I got confused, Chuck.
so
Yeah.
Mars is, even though it's a little dot like a star, has always appeared red, like a red dwarf star or something.
It has that color, yeah.
Mm-hmm.
Wow.
I don't think it's very big, but it's coming around the sun into the, what is it? It's leaving the evening sky or leaving the morning sky?
It's leaving the evening sky very, very slowly.
Yeah. Mm-hmm.
And it's in my chosen month, Taurus the bull,
Uh-huh.
zodiac,
Yeah.
11 degrees east of the 4-day-old moon.
Yeah, we were out about 8:30 to 9 o'clock, and it was, easily visible. And again, not real far from Aldebaran.
And it's going to make a nice pass by an open cluster M35, which I think Tom is
Oh.
showing here near the end of the
Yeah.
month.
Yeah, actually the real noticeable cluster there is NGC 2158 in the lower right.
Right.
M35 is the real diffuse cluster in the upper left.
Yeah.
And most of it's actually not in the photo here.
Okay.
That's right. Yeah. You have a good night when you pull out 2158. That's just beautiful, beautiful cluster.
So Mars is 5 seconds of an arc across, which is very small.
Okay.
For
Okay.
resolving it, you probably won't see any detail. They looked at Mars last Tuesday night in a sort of an outreach from Mount Wilson using the 60-inch telescope, but the atmosphere was so bad that you could not see any detail at all.
No.
It was a blob.
Yeah, it was a blob, a red blob, a blob.
Yeah.
Can one of you gentlemen answer me a question about transmission back to Earth from Mars, from our Perseverance and the Curiosities? Mars is trailing us now. We're passing it. It's soon going to be behind the sun, right?
Right. Well,
Mhm.
no, it's going into the morning sky, and then it'll go behind.
Yeah.
So how do they
There'll be
keep?
a radio blackout.
Oh, is that what it is? Okay, but are these rovers trained to turn their little dishes? They turn them sort of like your guidance systems on your telescopes toward the Earth as Mars.
Yeah, antennas, they communicate primarily with satellites orbiting Mars, such as the Mars Reconnaissance Orbiter. And then that orbiter relays the signals to Earth.
Okay, so even more the reason that it would have to turn the dishes to follow the satellites, or is it just?
Yeah, it's highly directional for the Mars Reconnaissance Orbiter.
Well, I got to tell you, this stuff from Perseverance is just awesome. That's going to do stuff for us for years.
Uh-huh.
We got about 5 minutes. It's Friday, Saturn's moon, Iapetus. I hadn't heard of that moon for some reason. How many moons? Saturn's got more moons than any other planet, right?
I think it's up in the
83, I
80s
think, at
now.
this point.
60. So
It's
change.
how many?
83, I think, is the latest
83,
number.
okay.
Wow.
Okay, well, Iapetus, I'm assuming that's how it's pronounced, changes brightness on Friday, the Saturn moon, 2 magnitudes as it rotates, dimming down from magnitude 10 to 12. Or am I looking at that wrong? Saturn rises at 3:20 in the morning. Oh, we'll all be up for that.
Yeah.
I am.
Gentlemen, I got to tell you, what a hobby.
Mhm.
You had another.
Saturn and Jupiter are wonderful morning objects, before the sun comes up. They're really nice.
Well, that's when we live. We're all vampires. I know that. We had another question set among Jerry's talking points. What made the iconic Whirlpool galaxy look like a cosmic fingerprint? And I believe that was answered.
That's very interesting. Those lines you see on the galaxy are magnetic field lines.
Mm-hmm.
So we got to look at both the galaxy like this, and you see it's very chaotic. It's not, the lines of magnetic field do not follow the lines of the arms of the galaxy. So the reason that we there's also farther down, there is a picture of the first black hole, and it also has lines in it.
Yes.
So they looked at the black hole accretion disk with with polarized light, and these are the magnetic fields around the black hole, and in this case, they're very uniform. And the way they're oriented, they interact with the ions, the charged cloud around this, through the Lorentz force, and they prevent this gas from falling into the black hole, and they force it to go up to each pole and then shoot out of the black hole as the beam from each end of it. So the ions interacting with these magnetic field lines accounts for the jets you see out of the thing. Now, one of our pictures says there's a galaxy, which is M87, and it says there's a jet coming out of it, but the thing that looks like a jet is actually a galaxy. The jet is in there, but this picture doesn't really highlight it. There are other pictures that show that, but this one was the one with the article. So,
and I was just going to add, Jerry, that in the New York Times last week, in the Tuesday Times, they had a really nice article about the polarized light, So they're starting to look at the black hole in M87 with polarized light.
Right, and that's the picture they got of it.
Yes, that's right. That's right.
These polarized light pictures were taken with a observatory called Sophia, which is an airplane with a 100-inch telescope mounted in it. And in the picture, you see the door is open so they can see out. It flies very high, above 99% of the Earth's water in the atmosphere, so it can see in the infrared. It doesn't see as far in the infrared as the James Webb telescope is going to be able to see, but it's this observatory that the data that they take through that lets us map the magnetic fields around there.
Yeah, that airplane, by the way, used to fly out of NASA Ames. And a good friend of mine used to take part in a study of how many meteors they would count, while they were flying up above the lower atmosphere anyway. But yeah, it's a big plane.
It's also got a bulkhead in the middle, forward of the door you can see, so the operators aren't there at the, they're in comfortable position in conditions.
Yeah, I was wondering who opened and shut the door. Jeez.
It's daytime. Now, what can you see in the daytime besides the sun?
Well, if you're up, you don't, the thing that clobbers our vision in the daytime is the scattering of light in the night sky. Why it's blue.
Yeah.
You get up here and you probably look overhead, the sky is no longer blue, it's black, even in the daytime.
And at the infrared wavelengths, you're not going to be bothered by scattered atmospheric light.
That's true.
I boo-booed on moons of Saturn. It's 82, not 83.
Okay.
Shame on you.
I knew that. We are out of time.
Go ahead.
Anybody want to say anything to close out our podcast? Because we're down to the wire, gentlemen.
Okay.
Yeah, you were talking about light pollution. They unfortunately fixed a street light that had been out for years across the street from my house. I went out and talked to the guy if they could do anything about the light pollution. And he gave me a phone number to call, a local one. It's called the Glida Planning. It's 805-683-5211. And the problem in my neighborhood is the pole poles are all warped toward the ocean, so the lights are up too high. They can't lower the lights, but they can put shields on them. So I'm going to investigate shields.
It helped tremendously in my backyard.
All right, we'll get an update from you next week, Bruce. Thank you, Bruce, and the two Toms, and Jerry, our president, and Mr. Chuck McPartland, outreach coordinator. Good luck to you. Stay safe. Give my love to your wives, and pray for getting back together in Farron Hall at some point before the year's out.
All right.
Thanks,
Thank you.
everybody.
Thanks, Tom.
See everybody next
you,
week.
Rod.
Thanks, Jerry.
1 o'clock.
Bye, Chuck.
Thank you. Take care.